Walk through the ZPA Transformation. A couple of engineers asked for a bit of a deeper dive run through of my setup. So briefly, I have a couple of managed devices here, managed with Intune. They're enrolled hybrid Azure AD joined. Got browser-based access, cloud browser isolation, access to these workloads. In AWS, I've got cloud connectors, I've got my app connectors, and I've got some workloads and a Bastion host. And in my data center, I've got a domain controller, I've got the Apache server, I've got my SAML environment here, and I've got a private service edge. So what I'll do, as much as I run through all of these different use cases, and we've seen those in the other video, what I'll do is I'll run through the actual raw setup, and hopefully this will help you understand how things are connecting and everything like that. So we'll start off, and I've got my domain controller. Domain controller is running my certificate services. So if I look at here, I've got, I'll open a couple of different things here, sites and services, users and computers, and I'll open up my certification authority. So let's start with certificate server, because I think everything kind of starts with certificates. I can able to issue user certificates, so that I can do certificate-based authentication to resources. You'll see this as I go through the demonstration. I show the different use cases. The Active Directory is incredibly simple. I've got a user store. We can see the registered devices. These are devices that are synchronized from Azure AD, so they're hybrid joined. So when we do device authentication, we can look them up and we can see that they're part of the domain and apply policy on that. I'm not going to go through the intricacies of setting up hybrid Azure AD joined devices, but it's worth looking at. Active Directory sites and services. So I've got a couple of different locations. This is worth paying attention to when you start looking into how AD enumerates sites and how we're going to figure out which domain controller to talk to. So you'll see this a little bit with SCCM. Which distribution point should I connect to based on my IP address and based on the site that I'm in? So a site, in this case England, is represented by a subnet. Anything in this subnet is in the England site. If I look at this one, anything that's in the Wales site is 192.168.2.0/24, so we can figure out which site they're in. Think US, America, or France, based on your different subnet. And so if I look here, this server here has a, which is my domain controller, has an IP address 192.168.1.2. It is automatically placed in the England site. When it comes to SCCM, you would then say this SCCM server is in this site, so any user that's also in that site would go and get its SCCM distribution from that server. So you can see a site is a subnet or a group of subnets. And when a client figures out what site it's in, what it's basically doing is making a connection to the domain controller and saying, what IP address are you seeing me come from, so I can figure out what site I'm in. And therefore it is really important that your app connector is in that IP range so that your users are seen in that site. And all of Active Directory is kind of based on a lot of that site discovery and things that go along with that. So you define subnets, map them to sites, and you can also have inter-site transport. So I'm not going to go into the intricacies of Active Directory too deep. So we've got those, we've got our certificate servers, and we publish certificate revocation lists. So that's my domain controller. What else have we got in here? We've got trusts, and I've got all my trusts here for ZIA, for Kerberos authentication. We're going to ignore a lot of that as far as this demonstration is concerned. So that's that one. I've got an ADFS server. This is my ADFS 2019. I've upgraded slightly just to be able to give me a little bit of control around device registration and AD join and Azure AD hybrid join, things like that. Let's start with my Reliant Party trusts. So I've got a bunch in here, sort by display name. So I've got all my Zscaler Internet Access ones. I've got admin SSO into each of these. Let's and then ZPA. So let's start with the ZPA one because I think it's important because we're really showing that. So standard kind of configuration in terms of I'm expecting a signed assertion or a signed request or auth request, my endpoints that I can then send traffic to, or my response to, I should say. Claim issuance policy on this one is basically saying, well, we've got a bunch of rules in here. So some of these are kind of legacy. This basically says bring my Windows account name and stick it. We're going to add it to a variable called temp. And if I wanted to transform that UPN, the suffix, I could rewrite it to anything I want, anydomain.com if I wanted to, if I really wanted to. So that's all kind of set up. I'm doing a couple of interesting things here. I'm sending across what's called the auth method reference. So how did I authenticate? I'm sending across things like the OS version, and I can pull the OS version out for managed devices because we do device authentication as part of a hybrid join or device registration against Azure AD. I can pull out the version of the operating system type on my Windows or on my Mac. What else? There's a couple of, I'm pulling out the group membership, the certificate issuers, country code. If we've got a country code now, this is important. This is the country code against the user object. So when I mark Ryan in the Active Directory, there's a country object. I'm from UK. Doesn't necessarily mean that when I go to access or I authenticate that I'm coming from the UK at that point in time. So they're two different things, but you might be able to do something with those. So those are my rules for ZPA. You'll also see in here I've got admin SSO configured. Admin SSO is obviously relatively simple in terms of the issuance policy. I'm just going to send across the name ID. The same is true for, let's have a think, edgewise I'll ignore that. ZDX admin, so my admin SSO for these, they just need to send across the name ID. This one is actually doing the rewrite that I was kind of talking about because it wanted something specific. And all of those kind of things. So that's my setup here. Authentication methods. So I've got, for anybody that's external, forms certificate and device-based authentication. Internal forms Windows authentication, integrated Windows authentication or Kerberos, and all of that. And I could play around with some of those on a per application basis. I do have a internet-facing version of that service. Not really much to see on it. It's an ADFS proxy. I won't jump into that. So let's start with the managed device. I've already started off here, so I'm going to do a K-list purge. So I've got no Kerberos tickets on here because I want to start with first principles. I'm going to launch Internet Explorer, and I'm going to go to the ADFS server. It's somewhere over here. ADFS, IDP initiated signing. And if I sign into the site, you'll see I get transparent sign in. And also you'll notice that ZPA isn't running at this point because I want to demonstrate this. And you'll also see that I got no Kerberos tickets. And the reason for this is if we do a sign in to ZPA, this is an IDP initiated sign in. So I'll end up on the page that shows you the assertion. You'll see a bunch of things here. It still knew I was M. Ryan, and it also then sees I'm a registered user. it sees my device identifier, so this is the GUID for my device in Active Directory. And the reason for this is I did device authentication, so the device and my certificate within the device was used to authenticate to the ADFS server as part of hybrid join, and you'll see it comes under password protected transport, so it's coming across as a device auth as part of the TLS negotiation. And here's where we pull out the OS version, the operating system type, display name of the device, and there was the country code as part of the user. So it's combining user attributes and device attributes. And this is really important because it's I can be the same user on multiple devices, and I want to apply a different policy based on the device type that I'm coming from and how I did authentication. Interestingly, if I launch Edge and I do the same thing, let's go to the ADFS server. ADFS, and we'll just double check this hasn't decided to refresh token. We sign into the site. At that point, Edge kind of decided it wanted to go and get a Kerberos ticket. So Edge does behave differently to ADFS. So it's also worth checking. You think something's working one way and it's not really working the same way. If we do that same page on here, sign in, you'll see that it did Kerberos authentication, integrated Windows authentication, and it didn't do the device auth. So there's a couple of little nuances just to play around with and understand what's going on under the hood. So if we go ahead here and we launch Zscaler, the Zscaler app is going to launch. It did device authentication. In fact, what we can do once this launches, let's open Zscaler. What we'll do is we'll log out because I want to actually show you kind of how we know that it's doing device authentication. Klist purge. Okay, and just remember that we do have the option to launch the browser if we wanted to, but if we sign in here, it's going to use the embedded IE browser at this point, kind of. And we can see that it didn't go and get a Kerberos ticket. Now we could go and look in the logs and look at the sample assertion, or we could do a bunch of other things, but we know that it did device authentication, and we're all enrolled here for ZIA, ZPA, and Zscaler Digital Experience. And so at that point, if we want to go and access the AWS Apache, that's all going to work. If we come across to the managed device with no Zscaler client on here, it doesn't have an option to do anything else. So again, we could go to AWS Apache, and in fact I'll start with pinging AWS Apache welshgeek.net, and you'll see that it's replying to the exporter. And if we ping the ADFS server, I can tell you that .9 is the ADFS, the internet-facing ADFS server, the ADFS proxy. So we know we're going to hit that. So if we go to ADFS welshgeek.net, IDP initiated sign-on. Nope, we're going to go to AWS Apache. We get redirected to the IDP and sign in. Now we didn't do Kerberos authentication because we're not part of the purge klist. Let's just, I want to demonstrate that from first principles. AWS Apache redirected to the IDP. The IDP at that point did device authentication. If we launch the browser with Edge and we do AWS Apache welshgeek.net, again, because it doesn't seem to be doing device authentication, I'm pretty sure there's some registry entry I'm missing, although I've spent way too much time trying to figure it out. I'm just going to do certificate authentication. So this is client certificate. Uses certificate authentication to redirect to the device, to log in, and I get redirected at that point. We could go to the ADFS server and do IDP initiated sign-on, and click ZPA on this one, and we'll see the I'm going to close that down because it's got a cached session. ADFS IDP initiated sign-on. to ZPA, because we want to have a look at the assertion, sign in with a certificate, and we can see here the auth method reference was X509 TLS client. So we could use that to apply policy, because we know that only a managed device or device that we've admitted into the domain will be able to get a client certificate. But of course, we don't get any of the device information because we don't have a device certificate. So there's a couple of, again, different nuances to the way that we can apply policy based on the user and the device type. So let's come across this unmanaged device. Unmanaged, it's not part of Azure AD. It's not part of Intune. It's not hybrid joined or anything like that. It's just a machine in a work group. So at this point, if we go to ADFS, I don't have any option to sign in other than using username and password. So we click sign in, mryan@welshgeek.net, sign in, and you can see here it's password protected transport, so the same as you would have seen in the assertion for my managed device. But that did device authentication, so the TLS connection was authenticated. So again, we get nothing in here. So if we then go to AWS Apache, we are now going to get put into isolation because we can apply a policy based on those attributes: a web client, password protected authentication, log in this way. So different nuances, different ways to control that policy. Okay, so let's come back across to the managed device, and I'm going to go back to the ADFS, and we'll sign into private access admin SSO. So I showed you how that was already configured. It shows me the sends across the name ID. We can see all those connections. Let's have a look at the application segments. So I've got that Apache server and I've got the AWS Apache server. These are both configured as browser-based applications. They are in my data center, so they're in the DC Discovery. Well, that one's in the DC Discovery. This one's in my AWS environment. And what I'll do, let me come across into my AWS environment. I'm going to sign in here. We'll start with CloudFormation just to run you through how this is actually set up from first principles. So I've got a CloudFormation template called Zscaler or Zscaler indifferent. And what this does is it creates two EC2 instances for the app connectors. It automatically provisions these into the cloud. If I jump into the template, it might make it a bit clearer. We're basically passing API keys into the template, and the API key goes off when we create a VPC. We dynamically create because we create the VPC, we create the subnets in there, we create a NAT gateway in there, we create the different subnets for the application, the app connectors and everything. And then we create provisioning keys. If we go to, let's jump into the private access admin SSO here. We automatically create provisioning keys, cloud app connector provisioning keys, which have the name of the VPC. So this gives me the ability to distinguish between the different availability zones, different regions. I could spin up an app connector in every single region, and I will dynamically create a provisioning key based on that and provision the app connectors there. We then also, if we look at these outputs, we create an instance ID, so we register it in Route 53. let's go ahead and I will jump into Route 53 in a second, but you don't need to see too much in there. Hosted zone name is my hosted zone ID, and I created it in US East 1A and 1B, so we've got high availability across those. We get a NAT gateway in each one. So if we come across to EC2, you can see I've got my two app connectors. One is in 1A, one is in 1B. My Apache web server here is in a subnet called the application subnet. I've got a Bastion host, which is a jump server. That's in a 1A subnet, so it's in the application subnet. And then I've got my cloud connector, which is in its own subnet as well. So I think about it as a kind of a three-tier architecture at that point. The important things to really consider are security groups and NACLs. So a security group applies to the instance. In this case, I'll show you the security groups. I've got a security group here that basically says anything can, I probably should tie this down a little bit, but any IP address can SSH into it, but this is in a private subnet, so it's not routable from the internet, and this can connect outbound to anything on any port, any protocol from the connector. The Bastion host, I thought I tied these down, but really the Bastion host should only be accessible from the app connectors. So we should have an ACL, which is, sorry, not an ACL, a security group, which is tied to the app connectors. The cloud connector should have security groups that say inbound. Interesting. This is saying anything can go 40, 80, or 22, 443, 80, or 22 inbound. It can connect outbound to anything. Oh, sorry, I'm on the Apache server, so that makes sense. And the cloud connector, if we look at the security group for the cloud connector, these are created by its provisioning confirmation template as well. We'll go across to the VPC because I think we'll get a clearer view of the subnets. We've got the default one, so let's subnet ID is that. No. What I want to do is that. Okay. So as I said, I've got 1A, 1B application subnets, Cloud Connector 1A, 1B, NAT Gateway subnets, and our private subnets. So the NAT Gateway subnets are internet facing, meaning they're internet routable. The NAT gateway has its own elastic IP address, so its route table basically says, send everything out through the internet gateway. The Cloud Connector subnet basically says anything from the Cloud Connector subnet, if it's in the private address range, it's linked local, it's within the VPC. Otherwise, send it out via the NAT gateway. So the Cloud Connector egresses to the internet through the NAT gateway. And then my private subnet where the app connectors are, these are they have a slightly more complex, I could probably summarize some of these. The app connectors are also going to go direct. Anything to the internet is via the NAT gateway. I don't want to send app connector to broker traffic through the Cloud Connector. I want to send it direct, so it goes out through the NAT gateway. Anything else must be anything within this range is local to the subnet, local to the VPC 172.32/16. But these ranges 10.1/16, 164/15, 10.254/19. Those are the IP ranges that we advertise through the Cloud Connector. So when Cloud Connector is doing ZPA subjugation or DNS interception, it's going to return an IP address within that range. So we want to send that traffic through to the Cloud Connector. And that's important there. And on the application subnets, a similar kind of thing. Okay, so we've got we'll come back across to the CloudFormation templates just so you can kind of see what else we had set up there. Cloud Connector gets built with this one, standard Cloud Connector sub template. Cloud Connector 1A actually sends through what domains do we want to advertise through ZPA for the Cloud Connector. So I've got a couple here: CentOS, as you've seen in the demo, the Apache server, my domain controller, and that client, because I'm going to do client-to-client communication, and that kind of trombones in through the app connector, back out through the Cloud Connector, because we need to spoof the client. And I'll show you that in a second. So we've got all those connectivity mechanisms. What else is of interest to you guys? So let's drill into that. So in terms of the application, for client to client, I've got this set up: desktop 5UQ SLP. That is the managed client. But to be able to do it through the privileged remote access, I needed to advertise, for client to client to work. If you look, we don't want a server group configured, because it's saying there's no server group configured. Go and see whether or not a client connector has advertised itself as being that FQDN. But when we're doing privileged remote access, that's a client, and it's initiating a connection. It's got to know where the server connection is. So what I've done is I've actually spoofed it. I create a server group. This is one of those really good examples of when you kind of do things that are kind of unnatural. So what I'm doing here within my servers is I've created a server called desktop blah. This is basically doing a DNS override, and it's saying desktop 5UQ. That's the FQDN. And I create a server group that matches it, and we call it here desktop blah, and it's so if I want to send something to that, I'm going to send it, and I'm going to advertise it through this app connector group. So the app connector in AWS, if any client says I want to connect to this FQDN, this app connector is the one that can handle it. And of course, we've already advertised it in DNS in AWS. Okay, so we'll know it'll be able to be resolved in AWS, and the way that it's resolved in AWS is that the Cloud Connector is going to respond with that spoofed IP address. So we've got two parts of the puzzle there. And so in my application segment here, I've got something called RDP. RDP.welshgeek.net is this device here. So it says somebody who tries to connect to this host, it's actually this server group. That server group triggers the DNS resolution through the app connector that then sends it through the Cloud Connector. So it's a little bit of DNS jiggery pokery. So if we come across to, and this is actually going to fail, there's a bug. If we go across to privaccess at welshgeek.net, we can see this sort of machine here. So this is going to trigger the application segment called RDP, and that's then going to send it via the app connector. And I'm half expecting this is going to fail for a funny reason. Oh, nope, there we go. I'm probably a little bit disheartened by needing to fix it. So it's kind of a little bit of smoke and mirrors, just slightly to get that to work, but something that we should probably be doing as part of the platform anyway. So that's going on there. We've got the Bastion server, which is just an SSH, and then we've got the domain controllers and things like that. I still have. I don't know. I actually removed my. Oh no, yeah. So that's all set up. What else did I want to show you guys? Okay, so we'll jump into the privileged portal. So the privileged portal is here. Now there were some questions about certificates. So in fact, we'll jump into certificates here. So we have two different kinds of certificates. We have enrollment certificates, meaning when a device, a Zscaler client, or when a connector or a service edge enroll, they use these certificates. So a service edge will enroll. It'll say, here's my provisioning key. Provisioning key is issued by this, and it gets issued. It rolls up to this root. If we're doing isolation, the isolation client enrolls, so it's got this one here. And each of these just need their own. You need to select which one. Is it an isolation client? Is it the client connector? If it's selected as none, then it'll be based on the name. It's used for the connector or the service edge. And when you define the service edge, you select the certificate you're going to use. So there's the granularity on that. So these are for enrollment. These certificates here are, think of them as essentially web server certificates. Need to renew that one soon. And so this one is issued by my internal domain controller, and it's just a wildcard. Just remember, you need to have a subject alternate name as well as the common name on the certificate for your browser to match. So if I come across here and I go to the priv access here, we'll look at this certificate. Connection is secure. We'll look at the certificate. It is that wildcard certificate that we've uploaded. So we associate these certificates when we come across, firstly, to the privilege portal. It's using the wildcard certificate, and then within the console, which is linked to the portal, we say these are the application segments that we've defined that we want to advertise. We could create a couple of different profiles and different portals and advertise these applications out. The same is also true on the user portals. So a user portal, portal.welshgeek.net, we'll come across to that. These are some applications. These are the browser-based applications that we advertised. I've also advertised the Priv Access portal in there because I can advertise anything. I could advertise facebook.com if I want. It's just a link to make it easier for the user to click the link and go from there. But once again, you need to select the web server certificate, which is that wildcard certificate for that to work. And then there were some questions about inspection. So we've got our the OWASP top 10. I might have defined a couple of custom ones. The inspection profile here, that needs to do the same thing. We select the controls, different controls and everything. We don't want any overrides, things like that. So that's all good. When we come across then to the application segment, if we look down through these, which ones do we want to do inspection for? Well, we've got inspection set up for Apache and AWS, and again, this is where we would load up those certificates. So if I look at my web server, the Apache web server, and go direct to it, let's do this on my managed device. Managed, no CCC, managed with Zscaler client. Oh, I've closed it down because of that session, managed ZCC. There we go. If we go to AWS, let's go to that one and have a look at this certificate. This certificate issued to AWS Apache welshgeek.net. The issuer is DC1 and subject alternate name is AWS Apache welshgeek.net. If we then go across to let's go across to the managed no ZCC and go to AWS Apache. First thing, this is going through the browser-based access. So you will see that the certificate actually changes to the start.welshgeek.net. But it's actually happening in 2 points. It's within the browser, well, in the exporter, and also within the app connector, because we're doing the inspection on the app connector. So there are essentially 3 TLS channels. There's the client to the exporter connection. That's TLS. The exporter is making a TLS connection through to the app connector. The app connector is doing the inspection, so it's basically, think of it kind of like a reverse proxy on the app connector to do the inspection. Now, bear in mind that's also going through a microtunnel between the exporter, the service edge to the app connector. So you've got a TLS connection inside that microtunnel. The app connector is doing the inspection, and then it's creating the connection to that web server. Now that web server could be HTTP or HTTPS. It happens to be HTTPS in the background. So there's another TLS connection there. So there are 3 different TLS connections. There are one of those TLS connections is going through a microtunnel to the service edge. So there's a couple of different things going on there, and you'll see all of this in the ZPA logs if we come across the diagnostics. Here was our AWS connection. We can see the path that it took through the app connector to the AWS. There we'll see all the user metadata if we wanted to drill down as to what was going on, what attributes. As you can see, we've got all those SAML attributes there for that user. But we could see all of that path that was going through, as well as then understanding, because of this path, how that TLS inspection was well, it's not really TLS inspection, those TLS terminations were going on. So I've covered that. We've got our cloud connectors. I probably should just briefly, as you can imagine, a cloud connector enrolls with the client certificate. What we can do is we can go to connector.zscaler2. I don't think there's really that much to see in here. You can see that we've got the cloud connector, it's enrolled, it's in that AWS availability zone on US East. Again, similar kind of setup in terms of that. Things that are probably worth looking at, the IP pools. Here are the IP pools that I needed to make sure that I had the routing through the app connector for that to work. What else? So I showed ADFS. Let's jump into, before we get to deception, we'll go to ZDX. And for some reason, the ZDX admin SSO does take a little bit longer than everything else. I'm not entirely sure why. As far as this was concerned, I just put in the Apache server that we're going to check the cloud path for, and the web health and everything. If we select a user and we'll filter on the Apache server, click close, click apply, we do get all the visibility and the health. We can see that there's that user. I've got a couple of devices. I'm specifically interested in this one. And we can see the path through. We've got a pretty good score over time. I think it should be about 100, but I'm not going to argue with that. And the private service edge. And that's probably worth having a look at. So if we jump into the client connector, I'm going to jump into Zscaler 2. My private access is aligned with 2 different Zscaler cloud account. ZIA cloud account, Zscaler 2 and Zscaler 3, both with welshgeek.net. So I think there were some questions about that somewhere along the line. We'll just load up mobile admin. Let's jump onto this. So trusted networks. So this is defining my trusted network. If my router resolves to that, and I'm on 192.168.1.2 as my DNS server, I must be in the data center. That's kind of that condition for those things working. I think that's probably about the only thing. I could do some things with service entitlement. I don't happen to be, but could be doing a couple of things there. I had some device posture configurations. And so when we looked at private service edge, we can then use the trusted network to make that decision to be using that that private service edge based on that. Forwarding profiles, I don't think there's anything in here that's particularly contentious. No. Wellskeep tunnel, app profiles. Nothing in here that's really worth paying much attention to. We come over to service edges. Here's my service edge in the data center, which is using the service edge certificate, as I was saying. What's my IP address? And then which trusted network is that data center one that I created? It's not publicly accessible, which is why I'm not seeing those other users connecting to it. So I probably could do some things with that to make things a little bit faster as well if I really wanted to, but I only wanted to use it for the demonstration of those users. What else? Let's jump back into that ADFS server. We showed ZDX. Deception may be of some interest. The demonstration I did was relatively lightweight in terms of Zscaler deception. I showed that the user was able to connect to these two applications. I actually deployed the full client. I could have used the agentless, but I used the full agent. I had set up these two applications, one with web, this one had SSH on it as well. I think I showed the SSH on the demo. I created some decoy user file somewhere. Yeah, that one, and then where was I going? Deceive. Yeah, that was it. Agents. So I used the full agent install. That push down, that enabled you to understand what the user was doing on the machine, put those decoys in, put that file in there for the user agent and everything like that. But it was a very lightweight touch point for this demonstration. With that, I think that kind of shows everything. Let's just jump back over to my slide here. So I showed the browser-based access, the cloud browser isolation, the three different device types, access to the ADFS server, internal and external, the Apache server in both these locations, the connection into that and back out again, the private service edge. I show the deception, and hopefully that ticks all the boxes. Sorry, it was a bit of a long one, quite a little bit longer than the 10 minutes that I had for half time, but any questions, let me know. Mark@zscaler.com.